Good morning, everyone, and welcome to the Agronomy in Action Insight series. Hopefully, it's welcome back. This is our fifth of six sessions here this winter. So thank you for joining this morning. We're excited to have another hour of agronomy content prepared for all of you today. The topic for today's discussion is going to be around emerging Southwest corn diseases, and we're excited to jump in here. We have three individuals with us this morning to talk through this emerging corn disease talk. We have Adam Haig, who is the Golden Harvest Agronomy Manager for our Western Business Unit. He manages our agronomy team across a geography spanning from North Dakota to Texas and west of Interstate 35. He joined Syngenta after obtaining his bachelor's degree in agribusiness from the University of Nebraska at Kearney. During his 16 years with Syngenta, he has supported the business and sales leadership roles, was a member of the Enogen Fuel team, and joined the agronomy leadership team 2 years ago. The next presenter we have with us this morning is Bailey Jordan. She is located in East Central Kansas, covering Southeast Kansas, Southwest Missouri, and South Central Kansas. She holds a master's degree in crop production from Kansas State University, and she's been with Golden Harvest a year and a half now, but has been an agronomist for 8 years in various regions of Kansas and Missouri. The last presenter with us this morning is Erin Sim. She is a Golden Harvest agronomist located in Southwest Kansas, where she covers Southwest Kansas, Oklahoma, Texas, and the Southwest. She has a master's degree in horticulture from the University of Arkansas with an emphasis in plant pathology. Erin's been with Golden Harvest for a year and a half and has been an agronomist for over 20 years working in the southern states of the U.S. So really experienced and great group of Golden Harvest team members here with us this morning. With that, I'm going to pass it over to Adam to get us started here this morning. So thanks again for joining.
Good morning, Julia, and thank you for that kind introduction. I'm excited and honored to be here with some of my team members to focus on a couple diseases that really started to emerge in the Central Corn Belt here over the past couple of years. And quite frankly, there's still a lot to be learned about both of these diseases. But our goal today is to bring some awareness to what we know and offer some tips and insights on management. So if you look at the picture on the left-hand side, that is a picture that our team member Erin Sim took of corn stunt disease in her geography here this past year. Corn stunt disease has been present in the U.S. Sporadically over the course of the past 50 years or so, but in 2024 it showed up in a little bit more significant way than what it had historically. If you look at the picture on the left-hand side, that's a picture of late season decline. Late season decline really is a fairly new and emerging disease. You can see the telltale drought-like symptoms and early senescence in this picture. Basically, about 2023, Dr. Ken Obasa had identified a couple isolates on late season bacterial isolates and named them late season decline. And Erin Sim is going to take some opportunity today to educate us on that. So with that, let's go ahead and transition and jump into the first disease of the day, corn stunt disease. So the corn stunt disease complex really is a combination of 4 different pathogens. 2 of them are bacterial and 2 of them are viral. The first one, and probably the most common one, is corn stunt spiroplasma or Spiroplasma kuhn-kelly. The second bacterial is maize bushy stunt, and corn stunt spiroplasma and maize bushy stunt are really the true primary pathogens that we have seen in the U.S. over the course of the past couple of years. On the viral side, we have maize rheodefinovirus and maize striate mosaic virus. And collectively together, this disease complex has been referred to as accaparramento, or more commonly known as red stunt disease. And you'll hear a lot of people in the industry just refer to all these pathogens together as corn stunt disease. I would note that the symptoms with most of these disease pathogens are very similar, and some of the symptoms they're obviously common is given the name corn stunt, shortened internodes, a lot of smaller abnormal plants. Depending on the time of the infection, you can experience and see multiple underdeveloped ears. If you look at that first picture that I showed on the opening side, with the shrunken back kernels, that's a really telltale sign of reduced ear fill and what a lot of people in academia and the industry are referring to as the loose tooth syndrome. And then also, if you look at the picture on the right-hand side with the red margins on the leaf and the chlorotic leaf symptoms, those are really common signs and symptoms of the corn stunt disease. I'd like to kind of highlight a couple pictures from what we experienced, specifically in Texas this past year. So if you look at the picture on the left-hand side, you can see the purpling and the reddening of the mid vein and the compressed nodes and multiple underdeveloped ears on that left picture. In the center of the screen, you'll look at that ear on the left-hand side of that center picture, and you can really see those shrunken back kernels. I will note that not every plant is typically infected in the same way. In fact, it has been noted that some plants can become infected and actually become asymptomatic. Not necessarily saying that's what's happening in that picture, but it should be noted that plants can become infected and still become asymptomatic. And then I just really like that picture on the left-hand side, with the red leaf margins. I think that's a really common symptom that we experience in Texas. And I guess with that, I'd maybe invite Erin to offer some commentary on what she experienced, in the fields where she took these pictures and some of the other fields across her geography. Erin, you want to share some comments with us?
Thank you, Adam. Yeah, so these pictures were taken in the Panhandle of Texas in Hale County. I had just learned that this disease had showed up in the Panhandle area. And when we arrived at the field, we started seeing the disease throughout the field and started walking the field and everything. And we were able to capture these great pictures. And I think these pictures really show the symptoms that Adam just talked about. And all the fields that I have walked this year have shown different levels of these diseases.
Well, thanks, Erin. I know it's a challenge that you had to manage, here this year, and hopefully with what we covered today, we'll be able to bring some awareness to it and help others maybe identify potential issues like this in the future. You really can't talk a lot about corn stunt disease complex without first acknowledging the main vector. And the main vector for the corn stunt disease complex is the corn leafhopper, or Dobulus mattis. And if you look at the pictures on the right-hand side of the screen here, we have nice pictures again that Erin was able to capture in some of her fields this summer, with the adult in the upper right-hand picture, and an early nymphal instar of one of the adolescents. So when you look at the adults, they're about an eighth of an inch in length. They're tan to brown in color. They have wings that protrude past the end of their abdomen. And the real telltale sign is if you look at their head, you'll see two black dots in between their compound eye. The nymphs are a little more translucent in color. They have wing buds and underdeveloped wings, and both the nymphs and the adults kind of move pretty sporadically and are pretty hard to get pinned down and to be able to take pictures like the ones that Erin was able to capture. This insect is a phloem feeding insect with a piercing, sucking mouth part, which is how it transmits the diseases that it vectors into the various plants. I will say, if an infected adult feeds on a corn plant, it really takes a fairly short amount of time for that insect to transmit that disease to that corn. So it is very efficient at transferring the disease, to various corn plants once it has been infected. Once an adult feeds on an infected corn plant, it again doesn't take much time for that adult to be infected, but the disease does go through about a 3 to 4 week latency period in that adult before that adult can transmit that disease to another corn plant. So we'll go into some more detail here later on in our webinar, talking more specific about the corn leafhopper's life cycle and how just exactly how it transmits that disease. But before we do that, I'd like to jump to a quick poll question. And we've talked a little bit today, just about the progression and how corn stunt disease has been present in the U.S. Over the years, but this last year, it progressed in a much different way. And I guess I'd just like the audience to maybe answer this question and kind of ponder on how far north in the U.S. Has corn stunt disease been confirmed. So it looks like we've had a decent number of attendees answer. And, for those of you that answered, South Dakota, you would be partially correct. Interestingly enough, corn stunt disease was confirmed in, late summer, early fall in Dual County in South Dakota. So you are partially correct. For those of you that answered Nebraska, it is maybe suspected that it was in Nebraska where we had some adult corn leafhoppers detected, but we didn't have confirmed confirmed plant samples with corn stunt disease. And for the 7% of you that answered New York, you would actually be correct. So Cornell University actually did confirm corn stunt disease late into the summer and fall. So it's just really fairly interesting that a disease that had historically been in the southern part of the U.S. on a more sporadic instance last year really did move quite a ways north. So if you look at this slide here, this kind of highlights the native range of the corn leafhopper. So its center of origin is originally from central Mexico. It is pretty comfortable within the Mexico and South America into Brazil and Argentina. And if you look at the progression on the top of the graph here, it was first documented outside of its center of origin there in central Mexico in the 1920s in Puerto Rico. And really from there, it's progressed, outside of its native range on a somewhat, consistent, basis. So in the 1940s, it was described in the Rio Grande Valley of Texas. And as you got into the 60s and 80s, it was described into, farther north into North America, into Mississippi, and even into Ohio. But really, what really has the academia and the industry, really on alert is really probably the last 10 years. So in the 2015, it really started to expand in Central America and Brazil and Argentina. And quite frankly, corn leafhopper and corn stunt disease has become a very significant issue for the ag industry in those corn growing regions. In 2016, it did start to resurface into Texas. And like I mentioned, this last year, it expanded quite a ways north into the U.S., probably much farther north than what we had maybe anticipated. We had documents of a corn leafhopper itself documented up into Nebraska, Illinois, Indiana, Minnesota, and even Wisconsin. The leafhopper itself was documented here this past year. So it's hypothesized that, with some of the strong southerly winds and hurricanes and things of that nature, it really likely aided the northern distribution of the corn leafhopper this past year. So I'd like to talk a little bit now about just how the corn leafhopper, transmits the diseases that it vectors. So I mentioned earlier that, as an infected corn leafhopper feeds on a plant, it has the molecules of the spiroplasm stunt and the phytoplasm stunt diseases. And it takes a very short amount of time worth of feeding for those salivary glands to deposit those molecules and allow them to start to propagate and build up within that plant tissue. I will say, like I mentioned earlier, once an adult feeds on an infected plant, it takes a short amount of time for that adult to contract that disease, but it does take about 3 to 4 weeks for the adult to be able to transmit that disease to another plant. And in addition to that, it also takes about 3 to 4 weeks for a plant to start to show the symptoms of the corn stunt disease. So there is about a 3 to 4 week latency period, both within the adult to be able to transmit the disease and also within the plant to really start to show some of those foliar symptoms. And I'll say that, timing of infection is really important in terms of how aggressive, yield decline we're going to see. The most important time to protect, the corn plant, from infection is really kind of that early vegetative to, pre-reproductive stage. So, if you look at this picture and you have a corn leafhopper infestation come in and start to feed on a plant at that, V5 time frame, it's likely going to be, V9, V10 before you really start to see, those foliar symptoms start to show up with the stacking of the nodes and the, senescing of the corn leaves and the red margins, start to build up. But, if you have that infection start early on at say V2 or V3, you're looking at some pretty significant yield issues that could be associated, with those diseases that it vectors. So again, the most critical time to monitor is in that early vegetative. Another way that the corn leafhopper, does damage is actually through the feeding itself. So corn leafhopper feeding can cause significant plant injuries. So the feeding process actually creates a honeydew excretion, which can lead to black sooty mold formation, which you can see pretty clearly outlined in the picture on the right hand side here. And quite frankly, the earlier the feeding starts, the higher the risk is, for this black sooty mold development, which will inevitably lead to reduced photosynthesis. In the United States, given the fact that corn leafhopper's native range is a little bit farther south. The United States, the late planted corn and second crop corn is likely, at the largest risk of having, corn leafhopper infestations that could cause issues with, black sooty mold. I have some pictures here from some of our colleagues within Brazil that I think do a really nice job of highlighting what I was just talking about from the feeding perspective. So you'll see where the arrows are highlighted out here that you can see, the honeydew excretion starting to build up, which will invariably, start to turn into that black sooty mold, with further development. Another really nice thing I'd like to call out within this picture is, this is obviously a very high level of infestation. And like I said, this picture came from some of our colleagues within Brazil, but you'll note on this area some of the white formations that are there. And I guess I would just note that, corn leafhopper adults lay endophytic eggs, meaning that they're laying the eggs up underneath that, upper leaf tissue. And, as the eggs develop, white microfilaments start to develop, before the adolescents actually emerge. And another thing I'd like to call out in this picture on the right-hand side is you'll see there's a lot of leafhoppers on that leaf, and they're in a lot of different growth stages. So you'll see a lot of different growth stages highlighted in this picture, along with, some of the exoskeletons that are there from the molting process of them transitioning into that next instar. So, and with that, I think this is a nice time and a nice opportunity to transition and talk a little bit more about the life cycle and development of the leafhopper, so we can maybe talk about some potential management practices. So with that, I think I'd like to, invite my team member, Bailey Jordan, to jump in to talk a little bit more about the corn leafhopper's life cycle. Bailey, I'll turn it over to you.
Thank you, Adam. So we've learned a little bit about the distribution of the corn leafhopper, as well as the signs and symptoms of their diseases that they vector. And I'm going to continue to expand on that. We're going to look at some management practices for the corn leafhopper. But first, I think it would be important to understand a little bit about their life cycle, as I think that'll help us understand some of these management practices that I'm going to talk about here a little bit later. So what we're looking at here is the life cycle of the corn leafhopper. And as we look at this, we're going to dive into what makes them so successful at building large populations. So if you look at this diagram, you'll see once a female corn leafhopper deposits her eggs, there's 5 instar stages before they become an adult, where they have their wings. They can then efficiently move from field to field. And then I want to dive a little deeper into what supports high populations. Like, what about the environment supports these high populations? They have a relatively short generation interval. So when we look at the time that the egg is deposited to adult, it's about 23 to 27 days. And this is relevant because it allows them to build really large populations. And that's important because as they build those large populations, you can have multiple generations of the corn leafhopper on one plant at one time. And that previous picture that Adam showed is a perfect example of that. And then they have a relatively long lifespan, or, you know, theoretically how long they live. So if you take a female corn leafhopper and she can lay up to 15 eggs per day over a span of 60 days would be kind of like their max longevity. That's almost 1,000 eggs over her lifetime. And then we look at environment and their host plant. Areas where we have more intense cropping systems, where you would have 2 cycles of corn in a year, allows them to move from green field of corn to green field of corn, where they prefer to feed and reproduce. And then when you look at temperature, temperature is arguably one of the most important pieces of the corn leafhopper, because their life cycle is very driven by that. And so when we get into environments that dip below freezing for long periods of time, they can experience significant decline in their populations. So I want to dive deeper into that temperature piece. So just like corn has a number of growing degree days to emerge, the corn leafhopper has a certain number of growing degree days to complete their life cycle, and that's just under about 1,200. And then when we look at when the corn leafhopper becomes an adult, they can kind of minimally survive in that 50 to 70 degree range. They can move to other grass species and kind of live at and not be reproducing and living efficiently, but they can kind of minimally survive. But then when we get into environments where they're below freezing temperatures, specifically literature mentions 23 degrees for longer than 3 hours, you can experience up to 50% mortality of their population. Temperature is not only important for the corn leafhopper, but also their host crop. So their preferred host crop is corn. And they will seek out a cornfield to feed and reproduce and lay their eggs. They can sporadically survive on other grass species, but they won't be reproducing to the level to build, you know, big populations. So the interesting thing about the corn leafhopper is we know that we've seen populations in areas where, you know, temperature is a limiting factor, and we've gone long periods without having fields of corn. So how do they make it there? Why do they get there? Well, I think there's a couple pieces to this equation. So if you look at this really close picture, it makes the corn leafhopper look really large, but it's a very zoomed in picture. If you see how large their wing structure is, it's over like 3/4 the size of their body. This allows them to efficiently fly from field to field. Then coupled with the fact that they're very small and light, the wind can move them. So when we have storms coming up out of the south with strong winds, this is what is responsible for moving them to areas way far north where we would never typically see them otherwise. The next thing we've got to think about is when we have populations established of the corn leafhoppers, they're going to be looking for the next green field. And so they're going to be looking at areas for where we have, 2 corn crop generations per year. They're going to be looking for other grass species to kind of survive to get to the next corn crop. And literature refers to this as a green bridge, and it allows them to bridge from their preferred area to feed and reproduce to the next. And an important piece of that is going to be managing volunteer corn. So typically in our area, the winter will take care of much of the volunteer corn, but we'll still see volunteer corn in a soybean field, for example. So they won't specifically target a soybean field, but what they will do is target the volunteer corn in a soybean field. And so this picture here where you see all the corn leafhopper on this one corn leaf collar is a great illustration of why it would be important to manage volunteer corn and how many one corn plant could host just unnecessarily on a volunteer plant. So this leads me to in-season management recommendations for the corn leafhopper. The key piece there is going to be in-season management, because as of today in North America, as a corn seed industry, there are no companies who have been actively screening and testing their genetic material for tolerance to corn stunt disease. And I think there's going to be a lot of appetite to get there. But as of today, we don't know as an industry what our corn germplasm tolerance is to corn stunt disease. So then when we look at in-season management, one of the most important things that we can do is protect that corn early in the growth stages when it's most susceptible to corn stunt. One of the ways that we could do this is to utilize a high rate of insecticide seed treatment. So for example, our Cruiser Max 1250. And then really from there, we need to be looking at scouting. And that's going to be easier said than done, because we need to be out looking in field edges where they tend to congregate. We need to be looking in leaf whorls and underneath sides of leaves, because they're really sensitive to the sun. So we're going to be looking in places where they're trying to really hide and get away from being exposed to the sun and the heat. And so if we are already walking out into the field and are able to just walk out and see large populations of the corn leafhopper, that's going to tell us that probably those plants have already been exposed to the corn stunt disease. And likely, those plants are infected if we are seeing some of the symptomology that Adam mentioned earlier. And currently there is no curative treatments for corn stunt disease. And so if you find yourself in a field and you think that it may need to be treated with an insecticide, I would recommend working with your local agronomist. There's a couple pieces that we need to identify. One is the growth stage of the corn, and then 2 is really need to be looking to make sure there isn't already some symptomology going on out there, to make sure that it would be a profitable application. Now, literature calls out a couple different insecticide active ingredients that is known to be active on the corn leafhopper. That would be dimethoate, pyrethroid, or chlorpyrifos. So again, those are some options if we find ourselves needing to make an application. I think there is going to be a large appetite to figure out some additional treatments in the future after the populations that we saw in 2024. Our colleagues in South and Central America have been dealing with corn leafhoppers for a lot longer at higher populations, just because of, one, their environment and their year-round temperatures, their intensive cropping practices, and just how long they've had the corn leafhopper established there. And so they're looking at some advanced practices where they would, potentially use a biological in with their insecticide treatment to help boost the efficacy of that insecticide treatment. And so I think if we find ourselves year over year needing to manage the corn leafhopper, they're going to be a great resource for us, as they have already been looking at some of these additional treatments to manage the corn leafhopper. Okay, so I'm going to wrap up here with just some concluding thoughts to bring all this together. So corn stunt, new emerging disease caused by 4 pathogens. It's vectored by the corn leafhopper, and that corn leafhopper's population is driven by environment. And then when we look at the long history in South and Central America, but it's newly emerging for us here in the US. The short generation intervals coupled with longevity of the corn leafhopper is responsible for the robust populations that they're able to build. And then in-season management is going to be key, because we don't know as a corn seed industry about the tolerance to corn stunt disease. And then again, it's going to be important to communicate with your local extension specialist and chemical provider if you think you need to make an application. So that brings us to our second poll question. This is going to be a true/false. The corn leafhopper can distribute to new fields by both wind and flight. Okay, so if you answered true, that would be correct. So if you remember back to that picture, I showed the really large wings. It allows them to move efficiently from field to field, but then also those southerly winds can help move them a great distance. So with that, I am going to pass it off to Erin, and she is going to talk about our next newly emerging corn disease.
Thank you, Bailey, and Adam. Lots of great information there. As we were walking fields that had corn stunt disease, we started noticing some corn in the field that was displaying some different symptomology. So after doing some research, making some phone calls to Extension and other researchers, we discovered that there is a new emerging disease in the Texas Panhandle, and that's late season decline, or LSD, as you'll hear it referred to by some people. So taking a look a little bit more about late season decline, it was first observed in 2020 and 2021 in the Texas Panhandle. This was at Bushland at the experiment station there by Dr. Ken Obasa. And as you look at the map on the right-hand side, you can see that that disease has since spread throughout Texas, into the Panhandle of Oklahoma, and even into Southwest Kansas. In the literature, it does talk about neighboring states, so it is unclear if this has moved into New Mexico and Colorado, or even further into Oklahoma. There are 2 or 3 different disease pathogens that are related to this corn stunt disease. We can't really talk about corn stunt disease without mentioning Pantoa stewarti. This is Stewart's wilt, and you may have heard of Stewart's wilt before, and we'll talk a little bit more about it as we move through the slides. But this is a disease that infects primarily corn, as well as other crops throughout the US. And a lot of the symptoms from Stewart's wilt are very similar to what we're seeing in late season decline. Pantoa innatus, this is the disease that is primarily responsible for causing late season decline. But after research and what Dr. Obasa has found, that this innatus has 2 different isolates. The first one being B566 and the next one being B623. And we'll talk about those a little bit more in just a moment. But with this Pantoa innatus in its isolates, that's when Dr. Obasa designated this as late season decline. And since then has been doing a lot of research on these. This is going to lead us into our next poll question. So Pantoa innatus is a widely known disease, but has been widely distributed. What is the distribution of this disease? So I'll give you guys just a second and take a look at that. Is it just North America? Is it across all of the Americas, North and South, countries with temperate climates, or worldwide? So we've got a wide variety of answers there, which is great. It is in North and South America, as well as countries with temperate climates. However, this is a worldwide disease. So taking a look at this map here on the right-hand side, you'll see that the disease is in the US as well as down into South America. But if you look a little bit further to the east, you'll see that across Europe and Asia, and even down into Africa and Australia, there are instances of this disease. So it is very widespread. Pantoa annatus has a lot of hosts there. It's found across many different crops, even things like cucurbits, corn, tomato. As you can see on the first bullet point, Sudan grass and onion leaf blotch are caused by Pantoa annatus, as well as wheat brownish lesion, tomato gray wall. And these are some of the crops that we are seeing grown in the Texas Panhandle and across those areas. The first identified Pantoa annatus was in pineapple in the Philippines in 1928. So this disease has been around for quite a while. And with the distribution of things like pineapple, that disease has made its way around the world. When Dr. Obasa was doing his research and learning more about this disease that was contributing to LSD, he started doing some RNA testing and discovered that there were two isolates that he had not seen before. The first one being B623. And this isolate he discovered contributed to that bacterial early decline of peanut. And this is important because we see a lot of peanuts grown down in the southern part of the Texas Panhandle and also over into New Mexico in that real sandy ground. The other one he discovered was the isolate B566. This one is most closely related to LSD. So on the B623 isolate, he found that about 86% of the time he was seeing that isolate in the corn stunt infected plants. But 100% of the time he was finding the isolate B566. So again, both these isolates are very important and they are extremely closely related to that Pantoa annatus. So let's take a look at a little bit of disease symptoms of this. As you'll notice in some of these pictures, there's some similarities to the corn stunt disease, and that was one reason we had a hard time identifying that there was another disease in a lot of these fields in the Texas Panhandle. The first thing is leaf streaking. We'll see some leaf streaking there that is in a white to a light green color. They have non-wavy margins and in some instances can look water soaked. The next thing would be poor development of the ears, and you can see that in those top pictures that I have on this slide. We see a lot of reduced pollination, and we'll talk about that a little bit in a second. But I think the main thing is that premature kernel dry down, and you can see that in that picture on the top right, where that those kernels just started drying down way prematurely. It almost looks like a kind of sweet corn seed. The one thing that we have noticed in the field and gives us some early indications that the field might be infected with late season decline is that drought stress of the plant. So in a field that is very healthy, has good water, and not seeing any problems with drought stress, all of a sudden in areas we'll see single plants or larger areas of plants that exhibit that drought stress. symptomology. The other thing is stunting of the plant. So what this disease does is it will stack those internodes really close together and really shorten up that plant. When we see that in corn plants, we know that there's going to be other problems, and that's what leads to these pollination problems and smaller ears. The last thing that we've noticed too is that the stalk lesions. So these lesions look very similar to hail damage. And at first, that's what I thought that this was maybe some hail damage or wind damage that we were seeing in the field. But as the disease progressed, these lesions became more. And as we started cutting some stalks open, we started noticing that there was a stalk rot in there. And then towards the end of the season, and as that plant started dying, we started noticing a lot of lodging of these plants out in the field. So this slide was taken out of a publication that Dr. Obasa was an author on at a Plant Health Progress in 2023. So a few of the pictures that I want to outline here, I know that there's a lot on this slide that you can take a look at, but the first thing I want to mention is picture A, where we see those lesions, where we see that streaking, very white in color. We start seeing the decay of the tissue on the edge. And then on the left-hand side of that picture, you can start seeing where some of those lesions are starting to look almost water soaked. That's very typical of this disease. The next thing is the picture B next to it. In the background, I know it's hard to see, but though that was a very healthy looking field, where just a spot right before it, towards the front of the picture, we see that stunting and the drought stress starting to show up in that field. The next few pictures I want to draw your attention to are F, G, and H down towards the bottom. So F, this is where we see that tassel senescence. This is when that plant really starts shortening up, those internodes start shortening up. That tassel just does not produce the way it should. It does not grow the way it should. And then as a result, we have poor pollination. The tassel dies prematurely, and we get that result of just that real sporadic pollination. The other thing that contributes to the poor pollination is in G, where those ears, they just don't develop right. And then we see some of the silk rot and abscission of the silks, where that those silks just don't pollinate. And then the last picture is a great picture of that stalk rot and then the lodging that we see with those lesions from the disease. So we can't talk about a disease without talking about how it impacts the crop. So the main thing that we're seeing with this disease is yield loss, just like a lot of different diseases that are out there, even with like corn stunt disease that Adam and Bailey talked about earlier. This is due to that reduced pollination of ears, the reduced ear and kernel development, and then the lodging of that plant due to stalk rot. What the literature has indicated, they're seeing somewhere between a 70 to 90 bushel per acre decrease when a field is infected. Now, this could change drastically depending on the level of disease that is out in the field. What we have noticed in the field is that you could see some plants that are have disease and starting to die, and it might just be one here and there very sporadically through the field. In other areas, we can see large areas like this picture on the right, where we see a large area that looks to be infected by late season decline. So now we'll talk a little bit about management of late season decline. The one thing that I want to draw your attention to is the transmission of this disease. There is very little known on the transmission. Looking through literature, reading a lot of research that has been done on Pantoa annatus, there are two primary transmission points. The first being through soil. So this can be a soil-borne disease where it's, as that bacteria grows in the soil, the plant can pick it up that way. The other way is through insects, and Pantoa annatus can be vectored through thrips or through corn rootworm. And that can be done either through the beetle or through corn rootworm feeding. So there are a couple of different ways. Now it's unsure, and the literature that I have read does not indicate how the new isolate B566 is transmitted to the plant. So that's something that we'll need to keep an eye on, and keep watching for new research that's done through the universities and extension to understand how it is vectored. My recommendation there would be to, if you're in one of these areas that late season decline has been found, to keep your field clean, be scouting for things like thrips. And then if you do have a history of corn rootworm in your field, take those control measures to eradicate or at least try to control some of that corn rootworm, as well as rotation is a key to keeping that under control. That takes us into awareness and scouting. Right now, with where we're at this disease being new, it's just being aware of what might be happening in your field, and then scouting that field on a regular basis to see how that disease is progressing and how much of that field might have the disease. If you do find those plants that have symptomology on it, the best thing to do is take a collection of that plant, pulling leaf tissue out, or if it's very small and you're starting to see some symptomology on some small plants, pulling the whole plant out and getting it to a lab for testing. I'm unsure if there are any labs other than the ones in Texas that are able to screen for this. So if you do find this, my suggestion would be to give a call up to the extension office in Amarillo, where the pathology department is, where Dr. Canobasa is, and discuss with them if they would like that sent to their lab or to another lab for testing. And then, moving from a grain crop to a silage crop, if you are out scouting your field, you feel that you're going to really have a reduced yield on your grain crop, it might be something to consider going into a silage crop, so you're not losing quite as much of your crop there, and you'll still be able to have some return on the investment you've made into that corn crop. As Bailey indicated when she talked about corn stunt disease, there is no resistant hybrids or tolerant hybrids at this time, and that is also true for late season decline. We're just unsure of that. And with this being such a new disease right now, there's a lot of work being done on understanding the disease, the distribution, and how it is moved from field to field. And from what I have learned and read, there is some efforts that will be taking place starting this next year, and starting to look at some resistant hybrids and doing some screening. But I think we're still a few years off from actually knowing where we're at there. The last thing I want to discuss is kind of taking a look at the diagram I have on the right-hand side with the disease triangle. You can't really talk about diseases such as corn stunt disease and late season decline without understanding how diseases work and how the different components interact with each other. So you do have to have that pathogen present to have a disease, as well as a host plant. If you don't have the right host plants out there, you're not going, that pathogen's just not going to be able to live. But then the third, and really one of the more important components to that, is that environment. You have to have that correct environment. And with the three of these components, then that's when you have disease and be able to take effect. Now, this last year, we saw this late season decline in a lot of fields, and the environment just was perfect for that. It's unsure what we'll see for this next year as far as growing conditions in the environment, to see if we'll have this disease show up and at the same levels as we had this last year. So with that, that takes us into our last slide of the presentation, and it's just to kind of summarize what we have talked about today. So Bailey and Adam did a great job going over late season decline and corn stunt disease, talking about the symptomology, how it's vectored, and some possible control measures going forward. And I discussed today late season decline and what we have learned so far with late season decline. I think we still have a lot of work to do. A lot of scouting in these next few years will really help us understand these two diseases a little bit more. With that, I'm going to turn it back over to Julia to wrap us up and give us some Q&A questions.
Thank you, Erin. Just trying to get myself off mute here this morning. What a jammed-packed webinar we've had so far. Appreciate all of the intel and insight from the three presenters here today. Bailey, I will start off with you here this morning. We have a question about the overwintering of the leaf hopper and their eggs. The question is, if we identified this pest in South Dakota this past year, will those automatically overwinter this winter so that they're going to be an issue next year, or will they have to blow up from the south?
Yeah, so as of what we know today, they do not overwinter. And, I know at least the environment in Kansas, we had some really long, extended freezing temperatures, at least where I'm at in Kansas. And so as you move north, I'm sure that they experienced, similar temperatures well below freezing, as we see, 23 degrees and below for longer than 3 hours. Literature calls out up to 50% loss in their population. And so I'm sure we were well over that in much of that area. And so as of today, no, they do not overwinter. It would require a storm to push them up.
One add I would have to that, and Justin Goodroad, I think, is the one that asked that question. So I guess congrats, Justin, and your seed advisor for submitting that sample to South Dakota and bringing awareness, to this emerging disease. I think when you type the question, you specifically ask, do the eggs overwinter? And I think Bailey did a nice job talking about it, but I think we need to clarify that, the eggs are going to be, laid underneath that top surface of the leaf and hatch, really before, we would even get complete plant senescence and the fall. And it's really the adult that if anything would overwinter, it would be the adult, not the egg. So there's no risk in the eggs being left in the residue. And to Bailey's point, with the environments that we have, there's likely very low risk that the adults would be able to overwinter in a majority of the central U.S. and especially South Dakota. One add I guess I might have in some of the literature, there are other species of leaf hoppers, the black-faced leaf hopper and the Mexican leaf hopper, that it's been implicated that they can transmit the diseases as well. But most of academia would say that there's somewhat insufficient evidence to say that they're as efficient or maybe can consistently do it like the corn leaf hopper can. So again, there's more to be learned, on other insects, but for right now, we're just trying to focus on the corn leaf hopper, and that's what we know about.
Thanks for that commentary. The next question that I'll pose for all of our presenters is around kind of silage quality. The question is, will these diseases damage the quality or taste of silage, and will it affect digestibility of that crop as well? Any thoughts there for either disease?
So I can start off with that. As far as quality, I would, I don't think there's no literature that really talks about that at this time, but looking at how these diseases infect the plant, what kind of symptomology you see, I would say that the quality will probably be decreased there. But and as far as like digestibility, I think that there's still some research that needs to be done on that, and needs to be looked at a little bit more. Maybe Adam or Bailey have some other comments on that.
No, I can add some comments, and then Bailey, feel free to chime in at any point. I would say undoubtedly, yes, but largely dependent upon time of infection. For the corn stunt disease complex. So if you're having an early infection and you're having those shriveled up kernels, like we showed, you're going to have lower starch content. If you have early leaf senescence and the buildup of sugars and that black city mold formation, you're just going to have less green matter and a lower quality canopy for basically a less digestible fiber is what I would say. Again, I'm not a silage expert, but just given the aggressive nature of corn stunt disease and how it kills leaf material and can kind of abort kernels and pull it back, lower starch and lower green leaf material, I think would ultimately lead to lower silage digestibility. Bailey, anything you'd like to add?
No, I think you guys covered it.
Great. Thanks for addressing that question. Another one that is in the chat that we might end on, seeing that we are getting close to time, is when it comes to the corn leaf hopper, does our current Viptera or Durcade traits guard anything against this pest?
I can chime in, and unfortunately, the answer is no. So there's no trait on the market that does offer protection against the corn leaf hopper. If we are trying to control that pest, it's relying on insecticide applications, either via a seed treatment that would translocate into early plant growth, or an insecticide application over the top, to kill the emerged adults. And I will say that they're a challenge. I mean, if you get in Brazil where they have high pressure, they're spraying multiple times in a season to try and keep them at bay, and it's not easy to manage. So we're hopeful and optimistic that with the environment that we have in the U.S., we're able to keep the adults further south in their native range, and it's maybe on an off chance that we have some strong southerly winds early in the season that will push them farther north into the U.S. But much is to be learned, and time will tell. So
thanks, Adam. We are at time, so I just want to thank everyone for joining us. If there are additional questions, please feel free to reach back out to myself or any of our panelists on the call today, or your local Golden Harvest agronomist. They can get you connected with anyone from this call as well. These are obviously things that are new and emerging. It's something to keep our eye on, and so I appreciate you joining, listening in on all of the research and documentation that we covered today. If you'd like to re-listen or forward it on to someone, the recording will be posted again to the Golden Harvest website via the landing page for this series. But I appreciate you all joining this morning. We'll see you next Thursday for our last webinar of our winter series. So thank you all, and have a safe Thursday.